There is something just absolutely mesmerizing about walking into a true artisan's workshop.
Oh, yeah. The actual workspace, right?
Exactly. Not the finished showroom, not where everything is all polished, vacuumed and put on a pedestal under warm lighting. I am talking about the actual back room, the workbench.
Where the real magic happens.
Right. You walk in, you see the sawdust on the floor, the meticulously arranged tools on the pegboard, the half-finished joints just clamped to the table.
Yeah, it tells a story.
It really does. You aren't just looking at a piece of furniture being built. You are getting a direct window into exactly how a particular mind works.
And, you learn far more from the grip than the walls.
Oh, that's a great way to put it.
Yeah, it's basically the difference between admiring the architecture of a completed house from the sidewalk and actually standing right there watching a master carpenter work.
Right, right.
The joy, the real learning, comes from observing how intentionally they hold the hammer. How they choose the specific nail for the specific wood, how they measure the angle before making a single cut.
And that is exactly the window we are looking through today on this deep dive. We have a fascinating source to explore, published literally today, March 17th, 2026.
Hot off the presses.
Hot off the digital presses, yeah. It is an entry from a blog called kianmenning.org. And the author, Ang, refers to himself as an old software plumber.
I love that phrase.
It's so humble, right? He spends his nights tinkering with free, Libre, and open source software, or FLOFS as it's known.
Right.
Now, the specific post we're looking at is titled Notes on Haskell Programming, Part 84, Handling Multi-Byte Characters Effectively.
Which, it sounds incredibly niche, I know.
Highly technical, yeah.
But the mission of this deep dive is to use this highly specific coding challenge as a magnifying glass for a much bigger philosophy.
Because Ang's dilemma in this post, it really offers a masterclass in critical thinking and intentionality.
We're looking at a blueprint for how to learn efficiently, why it is vital that we question the default settings in our lives, and really the hidden beauty of being incredibly, almost painstakingly precise in whatever craft you pursue.
Okay, let's unpack this, because before we can even begin to talk about the specifics of Haskell code, we have to talk about the workbench itself.
We need context.
We do. We have to talk about who we are learning from and how he approaches the act of learning. When you look at the sidebar of Ang's blog, it is just a staggering archive of knowledge dating all the way back to 2011.
It's massive.
It is. And to give you a sense of the sheer volume here, by March of 2026 alone, barely a quarter of the way through the year, he has already published 228 posts.
Wow. That's serious dedication.
Right. But what's fascinating isn't just that massive output. It's the application of a programmer's rigorous logic to literally every facet of everyday life. The blog is not just a coding repository.
Not at all.
You will see notes on Haskell programming sitting right next to notes on gardening.
Which is up to part 838, by the way.
Part 838, yeah.
Yeah.
He writes about propagating crown of thorns, dealing with leggy seedlings, and moving his basils.
And he approaches those plants with the exact same analytical lens he uses for his software.
He does. He tracks variables, isolates problems, documents the outcomes.
And the same goes for his notes on fish keeping, which is what, up to part 209?
Yep, 209.
He is tracking the water parameters for his betas and his snails with a kind of exacting precision usually reserved for debugging a script.
Right, like an actual scientist.
Exactly. He applies the scientific method to his diet, too, documenting the efficacy of icosapent ethyl and fish oil supplements.
Oh, and photography.
Yes, weighing the intricate pros and cons of dedicated mirrorless cameras versus DSLRs.
He dives into networking, analyzing MediaTek Wi-Fi 7 standards.
And of course, he's actively documenting his journey through multiple other programming languages beyond Haskell, like Blissor, Go, and Rust.
Not to mention, he is also actively supporting organizations that fight for open systems and digital rights, like the Electronic Frontier Foundation, the Free Software Foundation, and the Tor Project.
The man is just a machine of curiosity.
He really is. But looking at this sprawling, cross-disciplinary list of interests, I had to ask, is this level of hyper-documentation a distraction? Well, we are often taught to specialize, right, to pick one lane. Is meticulously writing down the pH of a fish tank taking away from his ability to be a great software plumber, or is it the secret weapon of a true polymath?
If we connect this to the bigger picture, this cross-disciplinary documentation is exactly what makes Ang's insights so incredibly valuable.
You think it feeds into the coding?
Oh, absolutely. It
Yeah.
is the engine of his entire learning process. He doesn't just passively consume information.
Right.
He treats every single discipline with the same rigorous observable logic, whether he's observing the germination of a seed in his garden, balancing the nitrogen cycle in his aquarium, or tracking down a memory leak in a server.
He's using the same mental muscles.
Exactly. He is training his mind to look for structural inefficiencies. When a mind is constantly honed to spot the root cause of a leggy seedling, it brings that same sharp diagnostic eye to a complex computer program.
Which brings us directly to the workbench and the specific puzzle that prompted today's post.
Right, the multi-byte dilemma.
Exactly. So Ang is working in Haskell, and he runs into a core plumbing issue. He is trying to print Chinese characters correctly on the screen.
Which is notoriously tricky.
It really is. For those of you who might not spend your days deep in computer memory architecture, these are known as multi-byte characters.
And to visualize that, think of a standard English letter as fitting neatly into a small, standard-size shipping box.
Okay.
It takes up 1 byte of memory. Very simple. But Chinese characters carry a lot more visual and linguistic complexity. They just don't fit in the small box.
They need more room.
Right. They require a larger, specialized shipping container, multiple bytes, to be stored and processed correctly.
Got it. Now, to understand the breakthrough Ang outlines in this post, we have to look at his previous, rather clunky method for handling these larger shipping containers.
Yeah, his old plumbing route.
Right. He was utilizing a modern data object called text. Now, text is brilliant for handling these complex, multi-byte Chinese characters. It is built for them.
But there was a catch.
There was a catch. The default command he was using to actually print the words to the screen, a function called prelude.put *rln, was an older tool. It couldn't understand the modern text object. It only understood a simpler, older format called a string.
So they weren't speaking the same language.
Exactly. So Ang was forced to use a middleman. He used a function called beta.text.unpack.
Okay, let's visualize what that actually means in practice.
Yeah, think about it like this. It's like taking a beautifully formatted, perfectly translated digital ebook. Then you print the entire thing out on physical paper. And then you put those physical papers into a scanner, scan them back into your computer as flat images, just so you can finally read the title on your screen.
That sounds exhausting.
It is. Yes, technically at the end of the process you can read the title. It achieved the goal. But it is completely inefficient.
Totally.
He was unpacking his nice, modern text object, converting it back into a standard string, just so this default print command could read it.
And that analogy perfectly highlights why this matters in the context of what Ang calls software plumbing.
How so?
Well, a plumber's entire job is to ensure smooth, efficient flow from point A to point B. Every unnecessary joint, every detour, every adapter in a pipe is a potential point of failure.
Or at least a bottleneck.
Exactly. At the very least, it is a loss of pressure. In software, efficiency is key, even on modern hyperfast computers. Every time you convert data back and forth unnecessarily, like unpacking text into a string, you're forcing the computer to allocate extra memory and burn through extra processing cycles.
And Ang realizes this is bad plumbing.
He spots the unnecessary adapter in the pipe.
Right, and he sets out to find a better route. He discovers he can use a different, highly specific command, data.text.io.put strln.
A bit of a mouthful.
It is, but this specific tool is built to handle the text object directly. No middleman, no unpacking. He can just take the complex multi-byte character and print it straight to the screen.
That's the dream. A good system designer of any kind always looks to remove those middle steps. You find the direct route, you save processing power, and the system runs cleaner.
But of course, in a simple world, the problem would be solved right there.
But we are not in a simple world.
We are not. In any complex system, solving one structural inefficiency almost always reveals the constraints of the environment you are working in.
Upgrading the pipe creates a new pressure problem down the line.
Yes. The plot thickens. We get to what I like to call the clash of the imports.
Ooh, sounds dramatic.
It is for a programmer. By trying to use this new, efficient command, Ang runs straight into a wall of defaults. If you've ever tried to save two files with the exact same name on your computer's desktop, you know exactly why the system threw an error here.
Right. Let's look at the architecture of Haskell to see why this happens.
Sure.
By default, every single Haskell program automatically loads a core module called Prelude.
Okay.
Think of it as the basic toolkit that the language always brings to the workbench, whether you ask for it or not.
It's just always there.
Always. The problem is, Prelude has its own command called put *rln, the older one. the one that only works with the old string type.
But now Aang wants to bring in his new specialized tool, which happens to share the exact same name, put strm.
Yep, name collision.
So now the program is staring at two different commands that look identical on the surface. The computer throws a compilation error because it is completely parallelized. It doesn't know which one he wants to use.
And Aang outlines two distinct ways to solve this collision. And his thought process here is a phenomenal lesson in system management.
What's the first option?
The first approach is the brute force method. Simply hide the default prelude version.
Just get rid of it.
Basically. He essentially tells the program, I know you usually bring this standard tool to the workbench, but leave it in the truck today. This clears the way for his new text tool to be the only one with that name.
Makes sense. And the second approach?
The second approach is to use an alias. Instead of hiding the default tool, he gives the new specialized tool a unique nickname in the code.
Oh, I see.
That way, they can both sit on the workbench side by side without confusing the computer.
Now, I have to push back on this a little bit.
Okay, go for it.
Because I think a lot of people listening might have the exact same reaction. Why not just let the computer figure it out?
What do you mean?
I mean, we live in an era of incredibly smart technology, right? Predictive algorithms, AI. Why do we care if there are two things with the same name if one clearly works better for the Chinese characters? Why jump through all these pedantic hoops of writing aliases or manually hiding imports?
Yeah, it can definitely feel tedious from the outside, I'll give you that.
Yeah.
But this touches on the absolute necessity of being explicit when you are building something meant to scale and last.
Okay.
You cannot rely on a machine to guess your intentions because the machine doesn't understand context.
That's fair.
Let's look at Aang's specific example in the post to see the danger of assuming the computer will just figure it out.
Walk us through it.
So Aang notes that down further in his code, he has a line that prints a very basic error message. Parse failed.
Mm-hmm. Okay, standard English.
Right. Now, that simple standard English text is automatically treated by the system as the old basic string type. It doesn't need the big shipping container. It fits perfectly in the small box.
Got it.
If Aang had used his first approach, if he had simply hidden the default prelude tool entirely to make room for his new one, suddenly his program wouldn't know how to print that basic parse failed message anymore.
Oh.
Yeah. The basic tool built for standard strings is gone, left in the truck.
Ah, I see. If you throw away the default everyday hammer just because you bought a specialized high-impact mallet for one specific job, you are going to be completely stuck when you just need to tap in a regular picture nail.
Exactly. You need both tools on the bench, clearly labeled.
That is the exact realization Aang comes to, right?
Yes. As he points out, using an alias, that second approach, is much safer when you're mixing different types of data in the same source file.
It allows the standard English error message to use the default tool and the complex Chinese characters to use the specialized tool.
Seamlessly, without stepping on each other's toes.
Here's where it gets really interesting.
Oh yeah, the twist.
Because Aang solves the immediate problem. The code works. The alias is clean.
Job done. Right.
You would think. But he stops, and he asks a question that completely pivots the entire blog post. He looks at his original clunky code, the one with the middleman, where he was unpacking the text, and he realizes something doesn't make sense.
Right.
He asks, why didn't the program raise a compilation error originally?
And that is the mark of a true artisan. He refuses to just accept that something works. He demands to know the underlying mechanics of why it works.
Yes. A lesser programmer would just say, the text is on the screen, I'm closing my laptop, good night.
Absolutely.
Yeah.
But Aang digs in. And he discovers that the specific testing environment he was using, something called GHCI, had a feature enabled by default behind the scenes.
The feature is called OverloadedStrings. Let's explain what that actually does, because it sounds like technical jargon, but it's actually a fascinating concept.
It really is.
When the Haskell compiler sees a word wrapped in quotation marks, it stubbornly assumes it is dealing with the old basic string type.
Right.
Overloaded strings is an extension that acts like an invisible, highly proactive worker on the assembly line.
Ooh, I like that analogy.
Yeah. When it sees those quotation marks, it secretly intercepts the data and upgrades it to the new, modern text type in the background without ever asking the manager. It magically translates the data so the program doesn't crash.
It was acting as a hidden safety net, basically making things work without Aang explicitly telling it to.
Right. And when Aang looks at this hidden, helpful magic, he completely rejects it.
He hates it.
He really does. He writes in his post, quote, "I'm not a big fan of enabling language extensions just for the sake of it." He ultimately declares that using his explicit alias approach without relying on this hidden background magic is fundamentally better.
And, to me, relying on that hidden extension is like driving a car with lane assist permanently turned on.
Oh, that's a good comparison.
Yeah, sure, it keeps you from drifting over the line. It might even save you from a crash in the short term. But eventually, you forget how to actually steer the car yourself.
You get complacent.
Exactly. You lose touch with the mechanics of the road, the friction of the tires, the weight of the steering column. When the road lines fade, or when you encounter an edge case the sensors don't understand, you don't have the fundamental skills to course correct.
Right. Aang wants to feel the road. He wants to know exactly when he is turning the wheel and exactly why the car is responding.
This raises an important question, doesn't it? Why reject a tool that is supposedly designed to make your life easier?
Right. Why make it harder on yourself?
Because you synthesized Aang's core philosophy perfectly with that driving analogy. Knowledge is most valuable when it is deeply understood, not when it is automated away into a black box.
Wow. Yeah.
In the world of software plumbing, or really in any complex system, magic is incredibly dangerous.
Magic being the hidden defaults.
Magic means something is happening in your pipes that you didn't explicitly authorize, that you can't see, and that you might not fully comprehend.
And when a pipe breaks at 3 a.m. on a Sunday?
Exactly. When it breaks and you spent the last 2 years relying on magic, you have absolutely no idea where the leak is. You don't know the architecture of your own house.
You're just staring at a puddle in the dark.
Aang points out that his manual aliasing approach offers stricter type checking. What that means in practice is that the programmer is forcing themselves to clearly label every tool and explicitly state exactly which function is touching which piece of data.
No assumptions.
No assumptions. The programmer is fully in control. The machine isn't making choices based on hidden default extensions. Aang chooses clarity, friction, and strictness over a convenient but opaque shortcut.
It is the ultimate artisan mindset. He won't let a machine do the measuring for him if he doesn't understand the fundamental math behind the measurement.
He refuses to cede control of his workbench.
And, true to form, he promises at the end of the post that he's going to explain the specific mystery of how that overloaded strings extension got turned on by default in his next post.
Knowing Aang's staggering output, that next post was probably published about 20 minutes after this one.
Honestly, a safe assumption, given his pace.
Right.
So what does this all mean for us? We've gone from the massive, sprawling archives of qianmeng.org, past the betas and the leggy basil seedlings, deep into the memory plumbing of Haskell code.
And into a philosophical debate about naming conventions and invisible assembly line workers.
Exactly. But when we pull back and look at the whole picture, Aang's journey is a profound reminder about the power of intentionality.
It is a mindset that scales far beyond coding.
It really does. Whether you are writing a piece of complex software, whether you are meticulously curating your diet with fish oil supplements, or managing the delicate chemical balance of a fish tank, intentionality always wins.
Always.
Clarity always beats relying on unseen default magic. It is about taking the time to truly understand the tools you use every single day, rather than just accepting that they work and moving on.
Yeah.
It's about looking at your own workbench, whether that's a literal desk, a digital workspace, or a creative process, and knowing exactly why every tool is placed where it is.
And taking that a step further, I'd like you, the listener, to mull over a thought as we wrap up today.
Okay, let's hear it.
Aang promised to dig into a specific overloaded strings mystery in his next post. He refused to let the hidden default go unquestioned.
Right.
So look at your own daily workflows. Look at the software you use for your job, the financial routines you follow, or even the communication habits you fall back on.
The things we just do on autopilot.
Exactly. How many default extensions or automatic shortcuts are you relying on without realizing it? And more importantly, what underlying errors or lack of fundamental understanding might those comfortable defaults be hiding from you right now?
What a question to leave on. Next time you step into your own workshop, whatever that looks like for you, take a second to look at the sawdust on the floor. Ask yourself exactly who is holding the hammer or the default settings. Thank you for joining us on this deep dive. We'll catch you next time.